Good afternoon, everyone. I hope you're all well. We'll be doing physical metallurgy, momentum and impulse, paper 2, which is question 4. So, the first statement there says trolley X of mass 1.2 kilograms travels at 8 meters per second east and collides with trolley Y of mass 0.5 kilograms, which is initially at rest. So it's important, guys, to always read the statement before attempting the questions, because now in this case, at the statement there are values that you have to use for the following questions. So if like you didn't read the statements, now it will be hard for you to find what is required for the following questions, right? So now they say the velocity time graph below shows the velocity of trolley X before, during, and after the collision with trolley Y. So we have the graph there of velocity time graph for trolley X, right? We have velocity on the Y-axis, we have time on the X-axis. And then now we move to the first question, which is 4.1, which says, state the principle of conservation of linear momentum. So it's always important for you guys to always know your definitions and formulas for these questions, right? Because now it contributes a lot of marks towards your exam papers in terms of definitions, right, for physical sciences. So for the definition of principle of conservation of linear momentum is that in an isolated system, you know that the total momentum remains constant or is conserved, right? So now we move to 4.2.1. So what does 4.2.1 require? They say they want the velocity of trolley Y immediately after the collision. So they don't want the velocity before the collision. You're looking for the velocity after the collision. So you have, let's say this, it's trolley X, right? And this is trolley Y, right? So this one we can say it's moving east at 8 meters per second, as they said at the statement there, and collides with trolley Y, right? Which trolley Y is 0.5 kilograms, right? And then trolley X it's 1.2 kilograms, right? And then they said of mass 0.5 kilogram, which is initially at rest, meaning that this one initial velocity is at rest, it's not moving, right? So, and then what else was given? We can see that at the graph they say the velocity is 4 and 8. You can see like the graph, it's like this, right? We have 8 here and we have 4, which goes like this and goes like this. So meaning that at this part, it's at initial, it's moving normally, it's before the collision. The collision hasn't occurred yet. And then here at this part here, which is like 20.1 and 20.02, is during the collision here. This part is during the collision, during collision. And then this part here, it's after collision, when the energy has been lost. It's after collision here. After collision. And here it's before collision. It's before collision, right? So now we are looking for what? We are looking for velocity after collision. We have the initial velocity of block Y, we have the initial velocity of block X, but we don't have the final velocity of both blocks, right? So which formula we're going to use to find the final velocity of both blocks? So the formula we're going to use for that is that one of delta momentum initial is equals to delta momentum final, right? And then mass of X, initial velocity of block X, plus mass of Y, initial velocity of block Y, is equal to mass of X, final velocity of block X, plus mass of Y, final velocity of Y, of block Y, right? So now we substitute the values that were given to us there. We know the mass of X, of block X, it's 1.2, and we know that the initial velocity is 8, and it's moving towards the right direction, meaning that it has to be positive. It's not moving towards the negative direction, so it has to be positive. Plus mass of Y is 0.5, and then the initial velocity of Y was 0. right? It's equal to mass of X was 1.2, and then final velocity of X after collision, it's 4. You can see here the line indicates to you that the final velocity of X after collision, it's 4, right? It was given there on the graph. It's 4. This one was initial, as you can see our straight line there. So because also it's moving to the right direction, it has to be positive, because now this is greater in terms of kilograms, right? So as it collides with block Y cannot obstruct block X from moving towards the east, because now they differ in terms of masses. This one has a greater mass and it's moving at a speed of 8 meters per second. And this one is initial at rest, meaning that if this one collides with this one, both of them, it has to move towards the east, right? So now, mass of Y, we know that it's 0.5, right? And then we are looking for velocity of Y. Since the question said velocity of trolley Y immediately after collision. So this one is unknown because that's what we are looking for in this case. So now, after that, you just do your maths there, punch in your calculator. So 1.2 multiplied by 8, we get 9.6, right? It's equal to 1.2 multiplied by 4, you get 4.8, and then plus 0.5 final velocity of block Y, right? And then 9.6 minus 4.8, it's equal to 4.8. As you take this to the left hand side, the sign changes, and then it minuses 9.86, and then we're left with 4.8 plus 0.5 final velocity of block Y, and then you divide by 0.5 both sides, and then you get your final velocity, which is 4.8 divided by 0.5, you get 9.6 meters per second east, right? Also indicate your direction, guys. That is like important, always indicate it, right? This is our 4.21